everyone, I would like to present a project regarding packaging line automation using PLCs and vision systems. We are four members in our project: Al Mutaz Hassan and Shan Ahmad Faisal and Asma Tabassum Happy and myself Jyoti Bola. Let me introduce our project. In our project, we developed an automated packaging system using PLCs and various sensors. Our goal was to replace manually counting and packaging with fully automated, accurate, and reliable process. So nowadays, automation is really important because it reduces human error, increases production speed, and ensures consistent quality. So, in this literature, we studied several other articles and papers published by other authors. So, in this, these several studies help us to understand that PLC-based automation is widely used in packaging, drilling, and sorting systems. And they help us understanding typical components such as conveyor belt, sensor, robotic arm, and ladder logic. They also guided us in developing a safe and efficient control sequence for our own packaging mission. And I would like to explain one of the reference by Karnataka, which was published in 2014. It shows that low-cost PLC systems can still deliver high reliability when combined with proper ladder logic and interlocking and noise filter. So this informed our approach to building safe start-stop latching and conveyor interlocking in our project. So in the methodology, we used um, we designed the complete system outlay layout. So the system contained conveyor belt to move the products and photoelectric sensors for counting and robotic arm for packaging and packaging done sensor. This is for resetting the system. So once the layout was made, we select the hardware and integrated everything with the PLC. And the next, we developed the ladder logic in steps, starting from start-stop latching, conveyor belt, and ending with the counter logic and robotic arm activation. We also include interlocking so the conveyor automatically stops when the robot is moving and ensures safety. So here we implemented CTU counter along with the one-shot pulse ONS, and this avoids the sensor bouncing and ensures each product is counted only once. So we also added a reset mechanism using either the package done sensor or the manually reset button. So here we rugs all the built and tested individually in CodeSys before the system was run. So we simulated the entire sequence and debugged the problems for example, such as like interlocks, noise from the sensors and some other like timing issues. So here let me explain the layout diagram. In this, as you can see, uh, in this layer diagram, we shows the physical arrangement of all components. As you can see in the diagram, it displays how the product flows from conveyor belt and get detected by sensor, counted and stopped at the preset value, and then picked by the robotic arm for packaging. From the next slide, my friend Tapusan will explain.
Hello everyone. Rest of the slide I will explain. The next slide is PLC programming. On this slide I am showing the PLC programming that controls the entire packaging system. The ladder logic includes several important parts. First, we have the start and stop control, which keeps the system running using a latch so the operator doesn't need to hold the button. Next, we program the counter logic that counts each product passing through the photosensor. To ensure accurate counting on a one-shot pulse is used so the counter increases only once per product, even if the sensor stays on it for a moment. We also include the logic that activates the robotic arm only when the preset count is reached. Each rung in this program was created carefully to ensure the correct sequence, like start, detect, count, stop, robotic activates, and reset. This programming ensures the whole cycle run smoothly, safely, and without errors. Next, on this next slide, we'll discuss more for the PLC programming. This slide shows more detailed parts of the logic, especially for the CTU counter and the interlocking system. The CTU counter increases by 1 every time a product is detected using the one-shot pulse. When the counter reaches the preset number, meaning the required number of products has arrived, the system automatically stops the conveyor. At this point, the robotic arm is triggered to begin the packaging system. The interlocking logic here is very important. It prevents the conveyor from running at the same time as the robotic arm. This ensures safety and also keep the sequence correct. Once packing is finished, the reset signal from the packing done sensor or the manual reset button clears the counter, and the system is ready for the next cycle. So this slide basically shows how the system knows when to stop, when to activate the robot, and when to restart again without any manual counting or intervention. Next slide is our result. In this slide, the result confirmed that the system worked exactly as intended. The conveyor ran only in run mode and it stopped automatically during the robotic operation. The photosensor produced clean one-shot pulses, giving accurate product counts. At the preset value, the conveyor stopped and the robotic arm activated precisely. The counter reset worked perfectly, allowing the cycle to repeat smoothly. Overall testing confirmed accurate counting, safe operation, and reliable sequencing. Discussion. In this discussion part, we highlighted the advantage of automation over manual packaging. The system provides more accurate product counting, reduces human error, shortens cycle time, and ensure consistent packaging quality. Automation improves efficiency and offers repeatable performance without fatigue. Then we'll discuss conclusion. In conclusion part, the PLC-based automation successfully replaced manual counting and packing with a fully automated solution. The sensors and counters ensured accurate detection, while interlocks improved safety. The simulation and testing proved the system's reliability and efficiency, showing that the PLC automation is effective for small-scale packaging operation. In the reference section, we will add some references for this project. They include some journal articles, textbooks, and online resources related to PLC, sensor, and packaging system. Thank you everyone for staying with us.